Так, всем здравствуйте, доброе утро.
Hello, everyone. Good morning. It's 11 o'clock, and we are about to start the presentation by Dmitry Vasilyev, an expert on metrics. And he's going to tell us about Postgres on AWS. Hello, everyone. So today we are going to talk about Postgres and AWS and RDS, and AWS in particular. My name is Dmitry Vasilyev. I work for Coins company. Our job is to provide services of mobile wallet for our users. In some Southeastern Asian countries, Apple Pay, Google Pay that don't work. So we are part of this niche that exists there. We use Postgres as a kernel of our system, so it's in RDS since 2014. We've got a Russian-speaking team. If you like Python, Golang, and Postgres, then please join us. If we talk about the modern infrastructure, then the standard thing, de facto thing for a lot of companies is Kubernetes. And for me, it was my first experience working with Kubernetes production when I joined the Coins company, and it was a little bit of a containing factor for me because it was too much of a change for me. And in this report, we are going to take into consideration the peculiarities of working with Kubernetes when your application is hosted inside Kubernetes working with some kind of Postgres. So what does AWS offer from the point of view? Classical virtual machines, you see two instances from small ones to larger ones. There are also i3 instances, and there is fast ephemeral storage locating with those, and when the virtual machine is deleted, it's going to be lost. A lot of companies are using this, are employing this, they are backing up their data using such solutions as Petroni, but we don't do this. And AWS as well offers a certain network storages. So different types, different prices. For example, the best one is ID, where you can get about 50 IOPS per 1 gigabyte of allocated space, and you can also ask for a guaranteed bandwidth. So it's very convenient when a developer has a fuck up, so they wrote out a code that is not working properly, so they can increase the amount of IOPS, and then they can go down with that later. They promise that for the consequential recording, it will be from 1 to 2 milliseconds latency, write latency. The next type of storage is GP2. It's a working horse. It's the most simple storage. It provides, it delivers about 3 IOPS per gigabyte of allocated space, and delays are much higher, up to 10 milliseconds. But we are going to discuss its peculiarities a little later. And the standard HDD, so there we are talking about 500 or 250 IOPS, but the interesting thing about its throughput capability, you can use it for some cold data. It's going to be much cheaper than to use storages, sometimes partially cheaper. And under certain conditions, you can also deploy WAL there. And AWS RDS, they offer the management solutions for RDS. There are different various databases, vanilla, Postgres, Aurora. They're compatible with PostgreSQL, but we are using Postgres Vanilla. So how can we deploy Postgres and AWS? So we can make self-hosted solution. We can take EC2 instances and then connect EBS storage to it, and then we can work like that. We can deploy Postgres inside Kubernetes on RDS, and then RDS is basically is a EC2 with EBS storages connected, so they're all interacting with each other, or we can combine all these methods. But we are actually using combination of all these methods, but main instances are deployed on RDS in our case. We should talk about terminology a little for those people who don't work with RDS. The main term in RDS is the multi-AZ. We know that there are regions in AWS, for example, Singapore, and in this region there are several zones, data centers, isolated data centers. It's called viability zones. When you switch multi-AZ for RDS, then one instance starts working in one availability zone and another instance will be in a different availability zone, and between them there is a replication by a block device. Well, it is hidden, but you can read in some documentation that that's a block replication actually. And at that, the hardware, your replica, so it's not running the Postgres instance, but the hardware is can start in any moment, so and it can be done quite fast. And the failover is managed by DNS record. So if there is a failover, then the DNS record starts pointing at referring to some other instance. You should keep that in mind when you're developing solutions like PG Bouncer. A lot of people, they like to cache their DNSs. And from our experience, multi-AZ is really working on average once in a month. One of 10 nodes is being switched without losing any data. Of course, if you didn't toy around with this synchronized commit and you didn't switch it off accidentally. Advantages of self-hosted solutions will be obvious, will be evident from the cons of RDS. So we are going to talk about the cons of disadvantages of various solutions. First of all, about self-hosted solutions. I can say that self-hosted on EC2 is cheaper than a multi-AZ that is working on RDS, because for a fail-safe scheme, you need a master, you need synchronized replica and asynchronized replica. Of course, you can try to save more money, you can try to do something like Arbiter and an asynchronized replica to make it smaller, but we are going to be honest with you. If you are taking 3 instances of EC2, and if we compare it with one instance of Postgres, RDS, and multi-AZ, then it's going to cost almost similar, almost the same. But if you're going to use EC2, then you are going to maintain the backups, and to do that you are going to need extra storage, you need extra resources, so that you could test your backups, and these are additional expenses that you should keep in mind if you want to get the self-host solutions. And the maintenance of such solution is more difficult, is more complex than the RDS one. First of all, the failover. I'm not a big fan of the automatic failovers, because from my point of view, they will give you more headache and they will give you more problems than they would solve. Of course, it's a nice thing to have, but you better have it switched off. You better have it disabled. And from maintenance point of view, you will have to deal with backups no matter what system you code. There still will have some errors with backups. The thing is that from my point of view, AWS RDS is have more better tested solutions regarding backups, and most likely they're going to work better than yours because they know their infrastructure better. As for Postgres and Kubernetes, the thing is that it is more economically viable to keep small instances in Kubernetes, let's say 80 CPU, 32 gigabytes of RAM, but it's not enough for the modern systems. Modern machine, you will have to buy large instances to work with labels, to deal with labels. It will be some part of Kubernetes that will be isolated, separated from the general Kubernetes, which is strange. And then they also say that there are some problems in Docker with enabled Hugo pages. So if you are going to put a relatively large instance into Docker, then you most likely will have problems. I didn't check it really, but that sounds true. If you will switch off disable Hugo pages on large instances, then you will have sigfolds and other problems. And also the deployment of Postgres in Kubernetes is a difficult, complex thing. It can be compensated by the research of how Postgres behaves in the Kubernetes. And it could be a reasonable decision only if you host hundreds of instances. For a smaller amount of large instances, I think that's not really a viable solution to deploy this solution inside the Kubernetes. So what are the disadvantages of RDS if we compare it with self-hosted? First of all, no super user access rights. You are not going to have an access to certain administrator functions. For example, when you are doing something complicated, complex with the logical process, you can't make older system using console, command line, so there are other tools to do that. And that's very deep vendor lock. You can't connect to instances using replication protocol. You will not be able to make a synchronized replica. So you will get a synchronized replica that is called read replica. Yes, it is a fast thing to deploy and it's convenient to use, but it is asynchronized. And you're going to lose an access to the system tools. Yes, from Postgres, since Postgres 9.4, there are certain events and Postgres is developing and is becoming better and better, but sometimes we don't have enough internal data of Postgres. We want to see what the system do. So why does it use so much CPU, or why a certain process is stuck? And we can try to use GDB if you are working self-hosted, but it's easier to solve in RDS. And one big disadvantage that stands in the way of scaling is the single storage for everything, for server logs, for archive logs, for data. So you can't have any separate table space for cold data. You are going to have a default table space that you bought 15K IO, and you can't, and it is being spent on some cold storage. So it is an expensive storage, and you spend it on some historical data. So you should keep that in mind when you develop an application for RDS. So it is more viable to cut your bases, to work with smaller instances. So what are the advantages of RDS? So code physical SLA is quite high. It is given as 99.95. It can be lower actually, but in reality in real life, it's quite high. It's much less than 22 minutes per month. There is also backup options, and they really work. And as I said, probably it works better than something that you would have written yourself. The speed of recovery, the maximal speed that I managed to get is 10 megabit per second. Of course, these are all pretty good values, but still it is quite slow because the recovery from the snapshot, from the backup snapshot on RDS is being done in a moment, really quick, but there is certain lag between when your instance was deployed and your data was connected to that instance, got close to that instance. Failover, it happens from my point of view quick enough. What I mean by failover, it is the time when some physical problem was noticed with the former instance, and the new instance started working. So that's what I mean by failover. So the maximal times 5 minutes. And one more advantage is that there is no super user. I think it is a certain advantage because you have only stable Postgres versions and its extensions that are supported by it. And still, there is no version 12 in RDS. It's not supported. It exists in the preview. You can test how your application could work with it, but RDS hasn't released yet this version into commercial exploitation. And another advantage that a Mac developer wouldn't come to you saying that we need this extension for sure, no matter what, and he'll start sigfold the backend, or it will start losing data, which is even worse, and you protect yourself from unstable versions. So it didn't really attract me, so I had a plan to switch to self-hosted because it was something that I was more accustomed to. But to switch to self-hosted, we needed first to study to see how to work with RDS, and then those advantages that I found that it stopped me from switching to self-hosted. So let's talk about it. Well, first of all, about the management. You have a web interface, and it's legacy enough. It has a lot of weird buttons and weird checkboxes, but, well, you can use it. And you also have a CLI tool that you can use. It interacts with the RDS API and AWS, and using it, you can create a scenario, so you can prepare certain works beforehand. But to describe the infrastructure, this thing doesn't really work well. Usually the Terraform is used, and we also use it.
So first you have to study DB instance. By using this, you can specify type, memory, CPU, encryption option when storage is created. Retention policy can also be specified. So it's like something, I want my instance to be like this one. As I said, you don't have access to all the system, but some Postgres parameters, not all, can be changed, can be modified by using a parameter group. In fact, it's like a template with some features for Postgres parameters. There is access to parameters such as memory, storage size, mins and maxes. You can script some values for Postgres for different types of instances. Also, you have to specify how you are going to use these parameters, and this state isn't synchronized with a basic Postgres config, because in Postgres config there is a SIG-hub level, but in parameter group you have to duplicate this, or to think how you're going to apply these parameters. You have to specify like this parameter will be applied during the restart. Also, you can use DB instance for inventory checking. It's quite helpful. You can get reports how expensive it was at a certain point of time. I spent 1 week around to write first custom providers, and this week wasn't in vain, and in fact I recommend you to study Terraforms and to write your own providers. So when you create a feature and you describe it in Terraform, maybe Terraform will not be enough for some custom things, so it's good to have these custom providers at hand. Web UI is ugly. It is divided into 2 parts. So there is a main part when that you interact while you start working with any system. There are 2 types of logs and events. Event is like an external action on instance, like backup, failover, or when, for example, during restart, AWS RDS can sometimes change parameters, and it says like, well, my friend, you have logical replication enabled, and I think that you have to upload well senders. So there is no criminality so far, but I recommend you to check what actually was put into the log. And simple Postgres logs that are not very convenient, especially when it comes to checking them in UI, web UI. That is why I recommend you to publish your logs to CloudWatch. Access to logs will be accelerated. You will be able to download them, and also you can use additional CloudWatch functionality. So if we imagine conventional CloudWatch logs, they're quite thick. CloudWatch gives you additional functionality to look for these logs. I actually like CW utility. It is written on Go language. It's very functional and not very demanding, by the way. So what makes it special? You can immediately skip to the time that you are interested in, so you don't have to go through gigabyte logs and to look for the line, to look for the time. You can immediately go to that particular point in time, or just to cut that particular piece. Also, there is certain filter functionality. For example, you can get error or fatal messages in events. When it comes to error, so Postgres logs is just an array of lines, but event is a combination of strings. So if you have a plan and you are using auto-explain to write it to log, the event will be uploaded completely. So you can see a link at the bottom of the slide. Also, this functionality allows to filter your logs. It's not about making JSON logs that you put into a cluster that you index later on. You can just take your text and to say it is structured in that way, and I wanna, for example, I wanna get a field which is higher than 2000. Or I want to get logs that are longer than 2 seconds, and all this functionality can be combined, so you can choose any logs you want for a specific period in time, and it is more useful than standardized tools. Talking about logs, we can't go away without statistics. PG Badger has different solutions for statistics, but they're not very convenient, I would say, in my view, especially for production. That is why we have just written a small script that downloads 5-minute segments from CloudWatch. It runs PG Badger for incremental updates. So in that case, you have an incremental report. Also, out of this 5-minute log, you can pick up various useful information, such as failed authentications or other important server messages. For example, hash index crashed. Sometimes it happens if you still use it, but recently it was included into WAL. And also it just loops. It just closes and it builds incremental updates. Since you have no access to operating system, your eyes are your metrics provided by RDS. There are basic system metrics such as CPU, drive, network. Also, there are unique pieces of information on balances. As I said, when GP2 gives you 3 IOPS per gigabyte, it's not true. It can give you up to 3K of IOPS, but for a short period of time. It will equal to around dozens of minutes. The same feature applies to CPU, to indexes, TX indexes. So for a limited time, it can give you more CPU than you pay for. So for big instances, it is better to have enhanced system metrics. Apart from disk, CPU, and memory, you can also take a look at the processes that are ran on the system. You can check their status. So I really recommend these metrics. A utility that allows you to do this is called Pecona, but it has a couple of drawbacks. But this is a good starting point, by the way. First, it cannot get basic system metrics if you haven't enabled them beforehand. Also, it is not very efficient while working with CloudWatch queries. So in RDS, in cloud, there is nothing for free. Like 1,000 of queries equal to 1 cent in CloudWatch. Depending on the number of instances, you can actually face additional thousands of dollars in billing if you don't take any measures. Also, I would like to promote my own solution, which is called Gatherer. It is not oriented on metrics, but it is oriented on getting statistics. It's not about numbers, it's about specific queries, tables, and so on. It was designed in a way that it supports vanilla instances, and there is no need to install any additional functionality on a server. You don't need to have any additional extensions because it has its own database. It's Postgres database with timescale DB. By using this utility, you can collect different information, different statistic snapshots such as pgstat activity, logs, user tables, and your buffer pool too. So here you can see IOPS going up, and we see that there was a very long query on creating an index. And you see how long it took to execute this query. In my view, it's quite convenient to use this tool. Also, there is a very unpleasant thing. Some people think that sequential scans increase buffer size. Sometimes sequential scans on small tables in terms of shared buffers lead to the situation that read buffer is not allocated and the entire table goes to memory. Here we see that in buffer pool we have 5 gigs table with sequential scans. If we use CloudWatch for grabs, we see that the planner created a query to pull all buffers into a buffer pool. Truly, Postgres is using ring buffer just for big tables, which are more than 1/4 of the buffer. Given the size of shared buffers, this approach has become out of date. So we can put the entire table into shared buffers. It will work quickly, and you are not using your precious space for indexes. You are using this for tables instead. Also, it would be good if we could somehow control this behavior, and so Postgres could use page cache and not buffer pool. So what about balancers? Here, there are not many options, in fact. We've got PG Bouncer, our old friend. We've got Odyssey. When I started to working with Odyssey, I was young. It's too novel. There is no pause functionality, and it's good that Yandex put it into an open source, which accelerated Odyssey and PG Bouncer promotion, and we see more releases, which is quite pleasant. So we have chosen PG Bouncer, and let's take a look at the scenarios where it can be used. In my view, the main pros are stability. When you deploy PG Bounce in EC2, compared to Kubernetes, pods are being restarted continuously. If your application is not using pooling, so it doesn't have an embedded pool, any TCP connection breakup will lead to the error. That is why Kubernetes pods restart will trigger alerts. In terms of Kubernetes, config is located closer to applications, so you will configure PG Bouncer and applications out of one system, which is convenient than using EC2, which is isolated from Kubernetes. And also you can use Kubernetes to scale this solution and to deal with the problem that PG Bouncer is just one core process. That is why we decided to write a daemon, an agent which is called KubeBouncer, which is a combination of PG Bouncer and Kubernetes. It monitors Kubernetes secret updates, configs that you can update manually or by using Terraform module. Also, it monitors database availability. As you know, in Kubernetes, there are a lot of network interlayers, and all this virtualization sometimes fails. Sometimes you can lose DNS or whatever. That is why you don't need a pod that doesn't have access to external systems, to RDS. And this agent monitors database availability, and if something happens, it tells Kubernetes that this pod is not available, database is not available, and Kubernetes will just kill it. Also, it exposes metrics to Prometheus, and also it can perform a graceful shutdown, as I said. So talking about pros and how it looks. So in Kubernetes, it is like a service. It's a DNS record that is being transformed into an array of classical records. How shutdown is performed? Kubernetes sends sigterm. Then kube-balancer sends polls to PG-balancer. New clients can't connect to the pod and must select different A records by the libkube protocol. So it's like a classical HTTP behavior of clients. Then readness probe returns 500, and then pod disappears from DNS records, from DNS cache. So the information on that pod availability just disappears from the cache. And then kube-balancer waits for all clients to be disconnected. There is a certain timeout. If clients freeze, they will be kicked out. And this functionality is enough not to avoid alerts while restarting PG-balancer. Now let's talk about automation. Config is easily created by Terraform provider. There are problems while using PG-balancer, but I don't understand why people do not use dedicated virtual database for their applications. People say, I have my set, but then another application went in and I don't see it. I don't see it out of search path, some tables. So some people just combine all their applications to one virtual base that is connected to a physical base. Also, you can get a time ticket. So each application uses a temporary user, which is quite good in terms of security. So what makes me suffer? So we made some efforts to use streaming replication, but clearly it's not the best option. It's okay in the beginning, but then it just getting worse and worse. That's why we use logical replication to collect data, and then we deploy TP in EC2. So we have two instances, lead and backup. We just give read-only access to the TP instance, and then we use Debezium, Airflow, Athena, and so on.
Здесь представлено приблизительно.
So you can see scheme in here and instances with a logical replication. Two of them, one is quite large and the other one is smaller. To create logical replication, we need a large instance for the initial run. And then to support it and maintain it further, we can use the smaller instance. There is no sense to use the synchronous replication between these two because logical replication is stored at the master. So it makes more sense to create a separate fork of the replication to create two independent subscribers. If something happens to one of them, then we will just recreate another subscriber from the first one. Because the initialization, it affects not only the subscriber, but also the publisher. And there are famous articles by Avida when they are making logical replication using the logical snapshot, but it's too expensive resource-wise. We are using base backup for that. We are running out of time to speak about how it's done, but you can look at the side notes. So what are the unpleasant things about using RDS? Row-level logs are quite slow in RDS because they are using a low cache of small size that is embedded in the code. So if you're using a lot of row-level logs that is being dumped onto a disk, and for whatever reason, they are extremely slow on the multi-AZ, so we just added advisory logs before each row-level log so that we didn't get failed row-level logs. If we do this, we got a quite substantial profit, and we started to live a normal life in the contention applications. And regarding the security, so here there is a certain trick. The trick is when you create the temporary row with a small life cycle of the password, and thus we are solving the DDL problem. When you want to create a new table, the table will be created that has an owner role. Using an old application, using PG Bouncer and some other applications, they didn't use a large base, they used their own pool. It's really hard to find an IP address. It's hard to understand who's this client because they have only IP address and there are a lot of layers of isolation in Kubernetes, and you want to understand who is this client. So there is this trick when you forward PGApp name in a variable environment, and then you will see the pod name where the application name should be. And RDS not always is working perfectly all the time. Sometimes they have the network storage problems. Here you can see that one buffer, 8 kilobyte, it took about 13 seconds to read it. It's not really clear what actually happened here. Maybe some recovery took place when it was read. I really hope that what happened. And maybe just it was some network storage glitch. Sometimes, since it's a virtualization of sorts, if you look at CPU, there is some stills, certain percent of stills, and some active user is standing in the way that is using all same resources, so you can't isolate it completely, and sometimes you will have to change the type of instance to get rid of some peaks like that, of latency peaks like that. So if you see some anomalies, if you change instance, switch it and then switch it back, then anomaly could be solved. So doing this, you can avoid problems with the host. And also when you are running some operation, performing some operations to change the grid parameters using the web interface, some changes could lead to the restart of the instance. There is a link, there is an URL that you can click on, and you can see what parameter changes can lead to downtime. Well, actually, we have already exceeded our time, so thank you very much. Are there any questions? Good afternoon. The question is, you said that you are using Kubernetes and some next versions, and the question is, do you use it to deploy applications there or the Postgres itself? And if you do it for Postgres, then what were your reasons to do that? Once again, we deploy series instances on RDS. All the small fries like PGConf bases, we deployed in the Kubernetes. We are not afraid of losing it. So, well, we are afraid, but it's not going to cost as much. Well, of course, in Kubernetes, mostly we deploy applications, and there is some small, really small, tiny bases there too. Thank you. So hello, thank you for the report. I've got a question. You said about the PG bouncer, but the PG badger, there is the watcher data. Is it some kind of a script or it's a Lambda? No, it's a common script. Have you thought I will drop you here about Lambda? It's to put in log stream. We use Lambda for traditional stuff. To throw out security alert if we do this, then we use Lambda. But for CloudWatch, you can just put Lambda there, and then it is going to do it by itself. But there is authorization alerts, and okay, then great. Thank you for your presentation. The question is, following you showed a tool to collect the PG data. Why don't you use a PG exporter for Prometheus versus PG Watch? PG exporter, I want to store snapshots of the stat activity. I want to work them by SQL queries. I don't need vast metrics, some figures. I want to see text. I want to have SQL access to it. That's why I snapshot it. I make a database and I make my reports based on that. Okay, I got it. Thank you.